We've implemented the joystick in the last lesson. This lesson, we're going to create the motion of the character with the joystick. Attention everyone. The front button controls the player's movement. We are on the player node. Bound custom script component keyboard input. Then in keyboard input. Get custom script component player controller. On update method. Call the move method of the player controller. Pass the direction vector in. If we implement joysticks to control character motion, this approach is also used. It will be a little troublesome. We need to integrate the joystick UI component. Mount it on the player node. You also need to customize the joystick controller script component. It is also hung on the player node. One more question. We used two joysticks in this game. Subsequent right joystick. It also controls the aiming direction and firing of the player's firearms. What do you do? Could it be that the relevant control scripts of firearms will be followed up? Is it also mounted on the player? Then you can get nodes and components layer by layer. It's quite troublesome. And doing this, the coupling between the various components will be very high. It will make subsequent modifications and extensions very difficult. A good system framework should ensure high cohesion. Low coupling. Joystick UI and joystick control module. Not strongly related to the player. It should be placed on the rocker node alone. And the same goes for push button controls. But there's a problem with that. How to communicate between custom components mounted on different nodes. How to communicate messages and method calls between them. Here you need to use event subscriptions and publishing. Everyone can go to preview in advance after class. In this lesson, we will implement it in the conventional way for the time being. Because the game has a double joystick design. Left joystick controls character movement. The right joystick controls the aiming direction and firing of the firearm. So we can choose in the joystick controller custom script. Add a new property control object. Indicates the game object to be controlled by the left joystick. Press Ctrl plus S to save. Then in the editor, the associated object to be controlled is the player node. Notice that the player node object is associated here. The player's movements are in the player controller. The player's movement is controlled by the custom component player controller on the player node object. So, we also need joystick controller. Custom script. Set a private property. And initialize it in the onStart method. And finally, anytime. The position of the left rocker cap has changed. The location of the control object needs to be updated in real time. So it needs to be in the onUpdate method of joystick controller. Gets the direction vector represented by the current position of the left joystick. Then, when calling the move method of the player controller, pass this direction vector in. The left joystick can be realized to control the player's movement. Here's a problem that needs too much attention. In a SandMod game, the direction of movement is a three-dimensional vector. You can see that when you call the move method of the player controller. To pass a three-dimensional vector, the joystick UI can only represent two-dimensional vectors. How to convert a two-dimensional vector to a three-dimensional vector? The first thing to understand: coordinates system in joystick UI and the coordinates system in SandMod games. I'm going to give you a little sketch here. Red, green, and blue represent XYZ respectively. And the joystick controls it. Does it move in a horizontal plane? That is to say, here's how we see it from above. Let me compare it with you first. Do you understand? Do you understand? Did you find any patterns? Because the left joystick is the control character in the horizontal plane. Move back and forth left and right. So after the joystick UI is projected to the ground, the x-axis of the joystick UI is the same as the x-axis of the spatial coordinates system. And the y-axis in the joystick UI. The green axis here represents the y-axis. And the z-axis in the spatial coordinates system. It should be on the same straight line, but they go in opposite directions. We're looking at the top of the player's head. Hold down the right mouse button to scroll. So the red represents the value of x. The blue represents the z value. Here it is. Positive x direction in the UI. Positive x direction in spatial coordinates system. They are consistent, but the y-axis in the UI coordinate system is vertically downward. It should be in the opposite direction of the z-axis in this spatial coordinate system. But on the same straight line. It would be easier to understand. After understanding the principle, let's write the code again. It's very clear. And here's a quick snapshot. This is x in the spatial coordinate system. This is the z-axis in space coordinates. So, the y-axis in the UI corresponds to the z-axis in the spatial coordinate system, but it goes in the opposite direction. After understanding the principle, let's write the code again and it will be very clear. This direction is the direction indicated by the joystick. First, get the rect transfer object of the left rocker cap. Then get its location position. That's the local coordinates. Returns a two-dimensional vector because local coordinates are used here. The coordinates of the joystick are encapsulated in this object, and information such as length and width. Due to local coordinates, it's actually a coordinate point. When we talked about the representation of vectors earlier, it can be represented by coordinates, therefore we first obtain. It's like getting the purple arrow. It's a vector. It represents a direction of movement of the player. It's a rocker cap. In this object, it has a local position local coordinate. Is equivalent to an end point of this arrow, because it's the starting point of the arrow. Is a coordinate origin of its local coordinate system. In that case, we are equivalent to getting a purple vector in this diagram. This vector, actually pass it on to this player as its direction of motion. So, we want to convert the two-dimensional vector in the UI to three-dimensional vectors in motion. Then construct a direction of movement. Okay, so we were talking about correspondence. The x-axis and the x-axis are the same. Then the y-axis goes up to 0. And what about the z-axis? It's actually the opposite of the y-axis in the UI. Then it basically works. But there's another thing to consider. Also pay attention to the problem of vector normalization. Since it is to be normalized, never ignore the zero vector problem. Because zero vector players don't have to move. Just go back directly. If it's a zero vector, you don't need to move. Its die length. This is to find its die length. If the die length is equal to 0. Or directly like this. If it is a zero vector, we'll go straight back. No normalization required. No need to move. If it is not a zero vector, that means the joystick has changed. Represents a certain direction. We need mobile players. Then we normalize it. Why normalize? We've talked about this before. Then call the method where the player moves. Just pass the direction in. Because of this place. Direction multiplied by velocity. If we don't normalize this direction vector, Not only does it affect the direction of motion, it also affects the player's movement speed. Save. Run it. Left joystick. You can control the player to walk in any direction. Of course, you can also test it. What happens if you don't normalize? Put this note. Discover, it's noticeably much faster than before. So not normalized. Not only does it affect the direction of motion, it also affects the speed at which the player moves. What if you don't make this zero vector judgment? You will find it starts to move to the right. What does this mean? That means we normalize it. This line of code FX. Originally, if I hadn't moved the joystick, it should be static. So let's take a look. Why normalize? Instead, it will cause it to move to the right in the first place. You have this kind of development or debugging skill. Since it is affected by this line of code, that must be a change in the direction vector. I output it just before and after it's normalized. Value of moving direction. Add a logo in front of it. Indicates that it is before normalization. After normalization. After normalization. Let's print this vector again. Clear the console first, then run it. No problem found. I'll give you a screenshot. Zoom in a little bit. You will find that it was originally a zero vector. When it normalizes, it becomes 100. What do you mean? The x component is 1. Which is the x component? The red axis. That must be a movement to the right. And here's why. Why would you do that? Because even though zero vectors cannot be normalized, but in our game engine API, you can't let this method have no return value, right? Others have return values. Some are not suitable without a return value. So when we normalize the zero vector, just set the default to the subvector in the x-axis direction to 1. So remember one thing. Whenever vector normalization is required, we must consider the zero vector. Otherwise, there may be some bugs you didn't expect. So far, we have the left joystick controlling the player to move in any direction. So, the function of the right joystick, is it similar to the left rocker? So think about that. Next class, let's take a look at the function realization of the right rocker. After class, everyone completes the left joystick to control the player's movement by themselves. Realization of right joystick function under preview.